Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just absolutely love what we get to do, which is spend Wednesday nights here with you, going over math problems, talking about areas that you need help in, and just building that competence and confidence in you. Because that's our goal, is to get you to the finish line, to get you to that passing score. I need you to remember that it is not if you pass, it's when you pass. And that is the most important thing that we want you leaving here knowing. In fact, I wore my When You Pass shirt tonight. I don't know if you can see it. When you pass. Because that is truly our motto. It's when you pass. It's not if you pass. You can do it. Sometimes it feels defeating, but you can do it. And so that's what we want you to know, is that you can do it. I have a set of problems that we'll review tonight. If there is anything that you want me to specifically go over in the coming weeks, the problems are preset, and so I can't necessarily add a problem in tonight. But if you want me to go over anything specific in the coming weeks, please comment in the comment box and let me know. That just helps me cater these sessions to your specific needs. And that's why we're here, is to help you. I mean, don't get me wrong, I love doing this, but this is to help you. So if there are any math problems that you specifically want or concepts, let me know in the comment box or tag me on Facebook, and I am happy to include that in the upcoming weeks. I always like to do a get to know you problem before we get started. Makes it feel a little less, I'm sitting in front of a computer. So in the comment box, let me know where you're from, what test are you prepping for, and what other question? Where are you from? What test are you prepping for? And do Do you prefer, this is a good one. Do you prefer steak or seafood? That might be a silly question, but a good friend of mine texted me earlier today because they're going out for her birthday. And she was like, should I get steak or seafood at this restaurant? And so I prefer steak. I would prefer to get a good old filet all day long. But that is not everybody's cup of tea. Some people prefer scallops or salmon or halibut or sea bass. So I am a steak girl all day. I don't love seafood. So where are you from? What test are you prepping for? And do you prefer steak or seafood? All right. Without further ado, let's go ahead and get started. I'm going to set up my next week little section here. And then as we are working through problems, if there is something that you want to see me go over next week or in the coming weeks, you can just let me know. And yeah. Hello, Jaquita. It is good to see you. You're a surf girl, surf and turf. Why didn't I even think of that? Some people love both, and that's great. You want both. You want the lobster tail, you want the scallops, you want the fish, you want it all. I love it. That's my husband. He's definitely a surf and turf kind of guy. He wants it all. So yeah. All right, let's go ahead and get started with the first problem. A rectangular garden is 15 feet long by 7 feet wide. A gardener wants to spread a 3-inch layer of mulch over the entire garden. What is the volume of the mulch needed in cubic feet? What is the volume of the mulch needed in cubic feet? All right, so this is an interesting problem. Really, honestly, this technically could be a K6 through 12th grade problem because it includes basic conversions, which is a standard for all, not conversations, conversions. Wow, I can't spell. Clearly, I'm a math person. It includes volume of just a rectangular prism, which is K6 through 12. Yeah, and that's about it. So this theoretically could be a K6 problem. This is definitely GK all the way. This is definitely Praxis Core all the way. So this could be for everybody. Now, even though like 7 through 12 people, this problem might be a little bit on the lower end for you, the process that we go through is definitely not. Like they could definitely give you something like this with a triangular prism or a hexagonal prism or even like a cone or a cylinder. And so the process we go through is definitely valuable. So let's go ahead and draw our shape. We're going to draw our rectangular garden that's 15 feet long by 7 feet wide. All right, here is my rectangular prism. So the ground, which is this part down here, is 15 feet long by 7 feet wide. And a gardener wants to spread a 3-inch layer of mulch over the entire garden, which makes this right here 3 inches. What is the volume of mulch needed? So the common error that people are going to make is they are going to do 7 times 15 times 3 because volume equals length times width times height when we're doing a rectangular prism. If we're doing any other volume, it's area of the base times the height, but the area of a rectangle is length times width, hence the length times width times height. So all of that said, this is not correct because I have feet, and inches. I cannot multiply feet, and inches. I'm going to multiply feet, and then the formula, if I multiply times 3, is going to end up being like 3 feet of mulch instead of 3 inches of mulch. So I need to convert, and I need to convert on the front end of the problem, not the back end. I need to convert my linear measurements, not my cubic measurements. It's just easier that way, regardless of whether you're doing area, perimeter, volume, you always want to convert your linear measurements, which are the measurements that you have at the front end of that problem, the distance between two things. So I want to convert into feet. And you might think to yourself, well, why? It would be way easier to convert the 15 and the 7 into inches than it would the 3 inches into feet. You're not wrong. However, my answer choices, when I look at my answer choices, are in cubic feet. And because my answer choices are in cubic feet, I want my units to be in cubic feet. So I need to convert this into linear feet so that when I multiply feet times feet times feet, I get cubic feet. So this is where things get a little tricky. How do I convert feet to inches, inches to feet? Well, I know that 1 foot equals 12 inches, right? I'm converting inches into feet. So I'm going to line these up. 3 inches equals how many feet? Well, to go from 12 to 1, what operation am I doing? To get from 12 inches to 1 foot, what operation am I doing? I'm dividing by 12. 12 divided by 12 is 1. So to get to feet, I'm going to divide by 12. So I have 3 over 12 feet. Now, if I have a 4-function calculator, I can do it in my 4-function calculator. And that gives me 0.25. If I did not have a 4-function calculator, how would I go about dividing that with my pen and pencil? I can do long division. So I can do 3 divided by 12, keeping in mind that this is going to be a decimal. Don't be afraid of the smaller number being inside that division symbol. And that's going to be another common error people make, is people might go 12 divided by 3 and get 4, but that is not correct because I'm going to be less than 1 foot. I only have 3 inches. That is not a full foot. And when we think about that conceptually, it makes sense. But sometimes when we do it mathematically, when we're under stress, we're under pressure, we revert back to things that feel more comfortable. Math is not about feeling, right? And sometimes we have to remind ourselves of that. So I would add a decimal 0 here, and the decimal would line up right here. 12 can go into 32 times. 24, 30 minus 24 is 6. Add a 0, pull it down. 12 can go into 65 times. So 0.25 would be my answer for the division piece of that. So I now, instead of 3 inches, I have 0.25 feet. I can do 15 times 7 times 0.25. Again, if you have your 4-function calculator, this becomes very easy. I'll show you how to do it if you don't have that 4-function calculator. So 15 times 7 is 105 times 0.25. 105 times 0.25 is 26.25, which is B. Now, you're saying, how do you go about doing that if I don't have a 4-function calculator? Well, I can do 15 times 7, long multiplication, 35, 7, 8, 9, 10, 105, times 0.25. And then when I do this, placeholder 0, I know that I'm going to move my decimal point 2 places to the left because I have 2 decimal places represented in my problem. And so my decimal place is here, and I'm going to move it 2 places to the left because I have 2 decimal places represented in my problem, 26.25. Questions? All right, let's go ahead and move on to problem number 2. What is the length of the hypotenuse of the right triangle below? What is the length of the hypotenuse of the right triangle below? This one is so fun. I just love trig. It's it might be my favorite math. The length of the hypotenuse of the triangle below. So I am trying to figure out this length right here. So I'm going to call that X. This is definitely a 7 through 12 problem, but it's helpful for everyone to understand the vocabulary of this. What is the hypotenuse? What is a right triangle? A right triangle is a triangle with a right angle. That is definitely vocabulary everybody needs to know. So the length of that hypotenuse. So I can't do Pythagorean theorem because I don't have this length right here. But what I do notice, and this is something that if you're taking the 7 through 12 test, you should definitely start to like, I am immediately seeing that. I see I have a 90-degree angle and a 30-degree angle. So this, I immediately am thinking a 30, 60, 90-degree triangle, which tells me that this angle is 60 degrees. Because and this is for everybody, a triangle has 180 degrees. So if I subtract 30 and I subtract 90, I'm going to get 60 degrees, right? So I have 90, 60, 30. What do I know about a 30, 60, 90-degree triangle? There's a relationship there. So across from the 30-degree angle is X. Across from the 60-degree angle is X square roots of 3. And across from the 90-degree angle is 2X. And you say, how do you remember that? Like I can remember the X square roots of 3, the 2X, but how do you remember where each one goes? Well, X is going to be the smallest value, right? Because it's not being multiplied by anything. And so the smallest side is going to go across from the 30. 2 times X is going to be bigger than X times the square root of 3. How do I know that? Because the square root of 3 is smaller than 2 because the square root of 4 is 2. So the square root of 3 has to be smaller than 2. So X times something that's smaller than 2 is going to be smaller than 2 times X, which means it's the medium size across from the 60, which means 2 times X is the largest side, which means it's across from the 90. Knowing all of that, this value right here is going to be what? That is going to equal X square roots of 3. 18 is going to equal X square roots of 3, which means that this side equals X, which means that, and I'm going to erase this now, this side equals 2X, right? And that's the side that we're looking for. So now I can solve this equation for X, plug X back into here, and then I have my answer. So 18 equals X square roots of 3. How do I get X by itself? Divide both sides by square root of 3. So 18 divided by the square root of 3 equals X. But now I need to get rid of that square root in the bottom in the denominator. So I'm going to multiply, because it's just not standard form, by the square root of 3 over the square root of 3. What does that do? What does multiplying by the square root of 3 over the square root of 3 do? It does not change the value of this. Now, I can't just multiply by the square root of 3 in the denominator because that's changing the value of this fraction. But what does this equal? Anything divided by itself is 1. Anything divided by itself is 1. Anything times 1 is itself. So if I multiply by square root of 3 over the square root of 3, which is 1, and I multiply something by 1, I'm not changing the value of it. I'm just changing the way it looks, right? So I have 18 square roots of 3 divided by the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. Great job, Lizette. Now I can simplify this. 18 divided by this. Nope. 18 divided by 3 is what? 6. So X equals 6 square roots of 3. which means this side right here equals 6 square roots of 3, which means this side equals 2 times 6 square roots of 3, which is 12 square roots of 3. Questions about that? No? We're good to go? All right, let's move on to problem number 3. What is the value of tangent of 5 pi over 4? What is the value of tangent of 5 pi over 4? All right, y'all, the hair just went up because I was sick of wet hair being on my neck. So the value of tangent of 5 pi over 4, this right here is a unit circle problem all day. If you know your unit circle, you can easily answer this problem. So let's quickly go over unit circle. I love when it like creates a perfect circle for me. Okay, so here's my unit circle, knowing that this point right here is 1, 0. This point right here is 0, 1. This point right here is -1, 0. And this point right here is 0, -1, right? That's why it's a unit circle, because it's a singular unit. And I know that tangent is sine over cosine, right? Tangent equals sine over cosine. I also know that all of these points on my unit circle are cosine of x, sine of x. How do I remember that? Whoops, we disconnected. Did we disconnect? It says it's still connected. Here we go. It's thinking. Eventually we'll connect, and if we don't, we'll just, flip the screen and it'll be what it is, right? So all of those points are cosine comma sine. How do I remember it's cosine comma sine? I remember that because C comes before S in the alphabet. And so because C comes before S, and when we look at a coordinate point, X comes before Y, that's kind of how I remember it. Okay, this thing is being so sorry. Okay, so this is super weird. Like we have this happen sometimes where like my iPad disconnects, but I have never had it where it says that it's connected, but it's like hiding in the background. I don't know. So here's what we're going to do. We're just going to do this. Okay, so I know that I have cosine comma sine. So when I start to draw out my unit circle here, I'm looking for a pi over 4 angle. Well, all of my pi over 4 angles are going to be my middle angles. Anytime they give us a pi over 4 angle, it's my favorite, because pi over 4 is the one that's directly in the middle. I don't have to remember pi over 3, pi over 6. Pi over 4 is directly in the middle. So this one right here is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. It's literally cutting the top into fourths and the bottom into fourths. How do I know that? Because I remember that over here is 1 pi. And when I go all the way around the circle, that is 2 pi. So I'm literally cutting my 1 pi into fourths. So 1, 2, 3, 4. And I'm cutting my 2 pi into fourths. 5, 6, 7, 8, right? So the mistake that people make is they say that this is 1 pi over 4, and then they say this is 2 pi over 4. But you can't forget that this is 2 pi over 4, which equals pi over 2, and that's your pi over 2 angle, right? So this is pi over 4 right here, and this is why this is hard, but we can do this. So this is pi over 4. This is 3 pi over 4, 4 pi over 4, 5 pi over 4. So my 5 pi over 4 angle is down here. That's the one that we're looking for. That's the ticket. That's the money right there. Now, 5 pi over 4, all of my pi over 4 angles are square root of 2 over 2, comma, square root of 2 over 2. Those are all of the coordinates. Those are the coordinates of these ones, not the ones that are like on the axes, but that's kind of common sense. That said, if I'm doing sine over cosine and I do square root of 2 over 2 divided by square root of 2 over 2, do I need to go through all of that process? I don't, because anything divided by itself equals 1. So if I'm doing the value of square root of 2 over 2 divided by the value of square root of 2 over 2, I'm going to get 1. It depends if it's a positive 1 or a negative 1, though. If I'm looking at 5 pi over 4, I have a negative x value and a negative y value. A negative divided by a negative equals a what? A positive. A negative divided by a negative is a positive. So my answer is going to be a positive 1. My answer is going to be a positive 1. Questions about that? All right, I'm going to try to reconnect one more time and see if I can't get it to connect, because it is just so hard to do this without it connecting. So give me 1 minute while I reconnect it, and we'll see if this works. And if not, we'll just keep doing it the way we're doing it. We're one step closer. It gave me a code. There's the ticket. Come on. There we are. Yay. There we go. Okay. Let's move on to the next problem. The initial term of a sequence is 7. Each term in the sequence is 8/9 the amount of the previous term. What is the sum of the terms as n approaches infinity? What is the sum of the terms as n approaches infinity? All righty. So this is sum of a geometric series, right? This is sum of a geometric series. So the way that we go about doing this is we have the initial term of a sequence is 7. And each term in the sequence is 8/9 the previous term. So if I multiply 7 times 8/9, if I multiply 7 times 8/9, I get 6.2 repeating. And then I multiply it times 8/9. And really the best way to do this is to not do it with decimals, is to do it with fractions. So 56/9, and then 56/9 times 8/9 is 448 over 81. And like you can see the process, like it's just going to keep going and going and going and going and going. So what is the sum of the terms as n approaches infinity. In this case, it's truly just a memorization of a formula. Now, here's what I want you to think about. I want you to think about what makes sense here, right? Like 7/9 doesn't make sense because I can't, like, 7 plus something is going to equal something larger than 7/9. So 7/9 wouldn't make sense. Also, I'm not going to end up with a negative number because I'm just moving further and further and further and further into the infinite numbers that are getting closer and closer and closer and closer to 0, because it's 8/9 the term, the amount of the previous term, if that makes sense. So as I'm getting closer and closer and closer, as I'm multiplying, like 56 divided by 9 was 6.2 repeating. 448 divided by 81 is 5.53. And we're only going to keep going and going and going. So 7 plus 6 plus 5, we're already at 18. And we haven't even gone past the first 3 terms. So if I don't know the formula for this, like let's say I have no idea what the formula is, it's going to be C or D, right? It's going to be C or D. Now, the sum of a geometric series as it approaches infinity, an infinite geometric series, equals A divided by, so the sum of an infinite series equals A divided by 1 minus R. So A is the first term. R is your common ratio, so 8/9. So this is going to equal 7 divided by 1 minus 8/9. 1 minus 8/9 is 1/9, right? So I have 7 divided by 1/9. How do I go about solving that? Well, keep, change, flip, right? And that's for everybody, even though not everybody needs to know sum of an infinite series. How do I divide fractions? Keep, change, flip. So 7 divided by 1/9, keep it, change it, flip it. 7 times 9 is 63. But again, if I didn't know the formula for that, I could very quickly see that if I just started doing a little bit of this, right? So 448 over 81 times 8/9. 448 times 8 is 3,584 divided by 81 times 9, 729. 3,584 divided by 729 is 4.9. It's not going down very quickly. So this is probably going to be like 4.1. This is probably going to be like 3.5, like ish, right? Like if I'm looking at that patterning. And so 7 plus 6 plus 5 plus 4 plus 3, like we're not going down super quickly. So my sum is going to rapidly increase, and then it's going to taper off, right? Because I'm going to end up with like really small decimals. So the sum of the terms as n approaches infinity is 63. Now, if it said, what is the sum of terms 1 through 8, then you would use a different formula. But this formula is the sum of the terms if it goes through infinity. Questions? All right, let's keep going. Below is an image of a rectangular field. So if Sophia runs from W to Y to X to Z, how far did Sophia run? How far did Sophia run? All right, this is a fun one. So if Sophia runs, so let's track her path from W. So that's her start. To Y, from W to Y. to X to Z. How far did she run? So what do I need here to be able to solve this? I know that the distance here is 252. I know that this distance is 64, but you're like, why'd they even give me 64? I don't need that. She never ran from X to W or W to X, and she never ran from Z to Y or Y to Z. So why do I need the 64? It's a great question. So she runs from W to Y to X to Z. So I know I'm doing 252 plus something because I have this diagonal, which is a something, and I have this diagonal, which is a something. Do rectangles have diagonals that are equal in length? That's a good question, right? Let's explore that. So if this is 252, then I also know that this down here is 252. And if this over here is 64, then I know that this over here is also 64. So with that said, what I've really created is two triangles. There's one. And there's the second. I have two triangles here that have the same legs, which means if they have the same legs, they're going to have the same hypotenuse because they also have the same angles because we've got 90-degree angles here. Well, since I have 90-degree angles here and this is a right triangle, I can use Pythagorean theorem, Pythag theorem. What does Pythag theorem state? A squared plus B squared equals C squared, where A and B are my legs. And that's going to give me the length of my two diagonals. So I have 64 squared plus 252 squared equals C squared. Use my handy dandy calculator and we're good to go. 64 times 64 is 4,096 plus 252 times 252 is 63,504. Add those two values together. I get 67,600. And how do I undo a squared? Square root both sides. So C equals 260, which means that this is 260 and this is 260. So from W to Y is 260, then from Y to X is 252, then from X to Z is 260 again. So 260 plus 260 plus 252 equals 772 feet. C. Questions about that? All right, let's go ahead and do the next problem. Amelia wants to build a frame for a painting that she created. She wants to make the frame a 2-inch wood frame all the way around the painting. If her painting is 3 feet by 5 feet and wood costs $2.75 per square inch, how much will the frame cost? How much will the frame cost? So this is a fun one, and this is a very, very common story problem that we see across quite a few exams. So she wants to build a frame for a painting. So here's my painting. And there goes my screen again. So I'm drawing my painting. Y'all, you're going to quickly realize as I'm trying to reconnect this, that art is not my strength. Spelling and art are not my strengths. You know, math is my strength. Art is not my strength. Choreography for dance, all day my strength. Math, my strength. Drawing an art picture, not necessarily my strength. So we're going to give it some grass. We're going to draw a sun. And we're going to draw a girl. Okay, there's my painting. And she wants to put a frame around that painting. She wants to put a frame around that painting. So there's my frame. And the frame is a 2-inch wood frame. So I'm going to color it brown. And it's 2 inches all the way around. If the painting is 3 feet by 5 feet, so we have 3 feet by 5 feet. And wood costs $2.75 per square inch. How much will the frame cost? So I already see that I'm going to have to convert to inches. So I'm going to multiply. I'm going to convert my 3 feet and my 5 feet into inches. So I know that I'm going to have to multiply both by 12 because there's 12 inches per foot. So I have 36 inches and I have 60 inches. I have 36 inches and I have 60 inches, which means, so this is now 60 inches and this is now 36 inches. Value's not changing. I'm just converting it. I need to figure out how much area the wood is taking up because the cost is per square inch. So I need to figure out the area of just the wood frame. 2 different ways I can do that. I can find the area of this entire thing and then subtract out the middle, or I can cut this frame into smaller rectangles and do the area of this rectangle, this rectangle, this rectangle, and this rectangle, and then add them together. I think I'm going to do the area of the larger area minus the area of the smaller rectangle. So I'm going to do area of the big minus area of the small. Well, I know that the area of the small is length times width. Length times width minus length times width. I already know the length and the width of this rectangle. It's 60 times 36. So I can do that piece of it so that at least I have one piece of this puzzle. Let's go ahead and do that right now. 60 times 36 equals 2,160. So what is the length and the width of that bigger rectangle? Well, if I extend this out, this distance is 60 right here, right? And this distance right here is 36. What do you notice? We notice all those 2's, right? Well, this width is 2. This width is 2. So I have all of these 2's being added to my length and my width. So what is the entire length of this section? 60, 61, 62, 63, 64, right? And what is the entire width of this section? 40. So I can do 64 times 40 to figure out what the area of my bigger rectangle is. 2,560 minus 2,160 is going to give me the area of the frame. And I'm constantly talking to myself as I'm solving this problem, because what I don't want to do is lose myself in the steps that I'm doing. It can be really hard when you're doing a multi-step problem to remember what you're even solving for. So it's important that as you're solving these problems, you're mentally going, okay, I got it. I know what I'm solving for. So that's why I'm like, oh, I'm solving for the area of the frame here, so that I don't think that that's my answer, because I'm not done yet. Remember, the question asked me, how much will the frame cost? The question asked me, how much will that frame cost? So I'm going to do 2,560 minus 2,160, and that equals 400. That is the area of the frame. That is the area of the frame. Now, if I was running out of time, let's say I was running out of time, I know that I need to do 400 times $2.75. But if I don't even have time to punch that into my calculator, which answer makes the most sense with that estimation? Because sometimes we may not know how to solve the problem. We may need to use our answer choices to help us. Which answer makes the most sense, or which answer makes the least sense? A makes the least sense. I'm multiplying 4 times almost 3. I'm not going to get just $12 more, right? And it's not going to be B either. 400 times almost $3 is almost $1,200. So it's going to be bigger than 539, but it's not going to be 2,560. In fact, 400 times $2.75 is indeed 1,100. However, if we have to do quick math, mental math, and get this problem rolling, then that's absolutely how you can look at it. These are some of my favorite problems just because of the steps that it takes. Questions about it? Let's go ahead and solve problem number 7. I can't remember what problem 7 is, but that's going to determine if we have time for one more problem or 2 more problems. The table below shows Jasion's weekly science test scores from a 5-week time frame. If he scored a 78 on his science test for week 6 and an 82 on his science test for week 7, what will be the change from the 6-week mean and the 7-week mean? Interesting. This is an interesting problem. They did not ask us for the 6-week mean or the 7-week mean. They asked us for the change between that 6 and 7-week mean. So I'm going to very quickly add 6 and 7 to this. So what do I know about mean? Mean equals the average, which equals the sum of all my data points divided by the number of data points I have, right? Divided by the number of data points I have. So they asked us for the change, which means I'm trying to find the difference, which means I'm going to subtract. And if you have to know anything about mean, you will have to know how to do this problem. If there is anything about average or mean on your blueprint or your specs, you will have to know how to solve this problem. That vocabulary right here is important for everyone to know. So mean would be 85 plus 71 plus 94 plus 67 plus 88 plus 78 plus 82, all divided by 7. That would be the 7-week mean. The 6-week mean would be 85 plus 71 plus 94 plus 67 plus 88 plus 78 plus 82 divided by, not plus 82, divided by 6. So I'm going to do all of these together divided by 6. And then I'm going to do all of these added together divided by 7. Trina, I think your comment came in a little bit late. So if I answered your question, let me know. If I didn't, re-ask that question for me so that I can answer your question. All right, so 85 plus 71 plus 94 plus 67 plus 88 plus 78 equals 483. And I'm going to divide that by 6 because there's 6 data points. 80.5. Then I'm going to add all the blue data points. 85 plus 71 plus 94 plus 67 plus 88 plus 78 plus 82 is 565 divided by 7, and that equals 80.7. So what happened? What's the change from the 6-week to the 7-week? It increases by 0.2. It increases by 0.2. Questions? We have time for one more. Let's go ahead and rock and roll, and then we'll turn it back over to Dr. A. The table below shows the bowling score. Oh, this is a perfect one to end on since we just did a mean problem. The table below shows the bowling score of 5 students on the local high school bowling team. The score of 70 seems to be an outlier. Which measure of central tendency changes the most by dropping the 70 from the data set? Which measure of central tendency changes the most by dropping the 70 from the data set? So, mean is your average. Median is your middle data point. Mode is the one that appears the most. And range is your difference between your highest and your lowest, right? Here's the trick. Range is not a measure of central tendency. Range is not a measure of central tendency. We often lump it in with measures of central tendency, but range is a measure of variation or dispersion. And so while we often teach it with our mean, median, mode, it is not a measure of central tendency. And it is going to change by a drastic amount, and that is going to be the trickster answer. Your mode is not going to change at all. Your mode is going to be 122, whether we keep the 70 or drop the 70, because it's the only thing that appears more than one time. So it's not going to be mode. My median, 70, 122, 122, 135, 145. My median is 122 with the 70. And it's between 122 and 135, which is 128.5. So it changes by about 6. My average is going to be 135 plus 122 plus 122 plus 70 plus 145 divided by 5. So my average is 118.8. And then if I drop the 70, 135 plus 122 plus 122 plus 145 divided by 4, 131. Look at that drastic change when we drop that outlier. Your mean is typically going to be the one that changes the most when you drop an outlier, because that is factoring into that average. And so when you drop it, that average averages out a little bit differently, right? I'm glad I answered your question, Trina. Good to know. All right. Let me know in the comment box what you want me to see me go over in the upcoming weeks. I look forward to seeing you next week, and I hope that you have a great rest of your week. I'm going to turn it back over to Dr. A to close us out. Have a wonderful week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.